Interstellar travel has long been a dream of humanity. The idea of exploring distant star systems and encountering alien civilizations has captivated the imaginations of scientists, writers, and enthusiasts for centuries. However, the challenges and mysteries surrounding interstellar travel have remained elusive, pushing the boundaries of our understanding of physics, engineering, and the very nature of space and time. In this video, we will delve into the mysteries of interstellar travel, exploring the concepts, technologies, and possibilities that may one day allow us to journey to the stars. One of the fundamental challenges of interstellar travel is the vast distances involved. Our nearest neighboring star system, Alpha Centauri, is located approximately 4.37 light-years away from Earth. This means that even if we were able to travel at the speed of light, it would take us over 4 years to reach our destination. Unfortunately, traveling at the speed of light is currently considered impossible due to the limitations of space-time. To overcome the limitations imposed by Einstein's theory of relativity, scientists and engineers have proposed various propulsion technologies that could potentially enable interstellar travel. These include nuclear propulsion, ion propulsion, antimatter propulsion, warp drive, and solar sails. Nuclear propulsion involves harnessing the energy released by nuclear reactions to propel a spacecraft. One of the most promising nuclear propulsion concepts is the nuclear thermal rocket launcher, which uses a nuclear reactor to heat a propellant such as liquid hydrogen and expel it at high velocities. Launchers have the advantage of providing high specific impulse, thrust per unit of propellant mass, but their use in interstellar travel is limited by the amount of nuclear fuel that can be carried on board. Ion propulsion, also known as electric propulsion, utilizes electric fields to accelerate charged particles, or ions, to high velocities. While ion propulsion systems have been successfully used in space missions, such as NASA's Deep Space One and Dawn spacecraft, their low thrust limits their use for interstellar travel. However, advancements in ion propulsion technology, such as the development of high-powered ion thrusters, could make them more viable for interstellar mission. Antimatter is the mirror image of normal matter, consisting of particles with opposite charges. When matter and antimatter collide, they annihilate each other, releasing a tremendous amount of energy. Harnessing this energy for propulsion could potentially enable spacecraft to reach relativistic speeds. However, producing and storing antimatter is currently extremely challenging and prohibitively expensive. Inspired by science fiction, the concept of warp drive involves distorting space-time to create a warp bubble that allows a spacecraft to travel faster than the speed of light. While the concept remains speculative, recent theoretical advancements, such as the Alcubierre drive, have renewed interest in the possibility of warp drive. However, the energy requirements and exotic matter needed to create and sustain a warp bubble are currently beyond our technological capabilities. Solar sails utilize the pressure of sunlight to propel a spacecraft. By deploying a large lightweight sail, a spacecraft can harness the momentum transfer from photons emitted by the sun. While solar sails offer continuous acceleration, they are limited by the intensity of sunlight and the distance from the sun. Nevertheless, solar sails could be viable for interstellar missions if combined with other propulsion technologies, such as laser or microwave beaming. In addition to propulsion technologies, scientists and engineers have proposed several concepts and strategies for interstellar travel. These concepts aim to address the challenges of long-duration space travel, sustainability, and the preservation of human life. Some of the notable concepts include generation ships, cryogenic sleep, transhumanism, and relativistic travel. Generation ships are massive spacecraft designed to sustain multiple generations of inhabitants during a long journey to a distant star system. These self-contained ecosystems would provide everything needed for survival, including food, water, and energy sources. However, generation ships would require vast resources and face challenges, such as maintaining the mental and physical health of the inhabitants over many generations. Cryogenic sleep, also known as suspended animation, involves inducing a state of reduced metabolic activity in astronauts, effectively slowing down their biological processes. By lowering the energy requirements of the crew, cryogenic sleep could potentially extend the duration of interstellar missions. However, the challenges of preserving tissue integrity, preventing cellular damage, and safely reviving the crew remain significant hurdles. Transhumanism is the concept of enhancing human capabilities through technological augmentation. By merging humans with advanced technologies, such as neural implants or cybernetic enhancements, astronauts could potentially withstand the extreme conditions of interstellar travel. Transhumanism also raises philosophical and ethical questions about the nature of humanity and the potential consequences of merging with machines. Relativistic travel involves exploiting the time dilation effects predicted by Einstein's theory of relativity. By traveling at a significant fraction of the speed of light, time would appear to pass more slowly for the astronauts compared to those remaining on Earth. As a result, interstellar journeys could be completed within the lifespan of the crew, even if centuries or millennia pass on Earth. However, the challenges of accelerating and decelerating a spacecraft to relativistic speeds remain significant. Interstellar travel remains a tantalizing frontier that pushes the boundaries of our understanding of physics, engineering, and the human condition. While the challenges and mysteries surrounding interstellar travel are vast, the pursuit of reaching the stars fuels scientific exploration and technological advancement. As we continue to unravel the mysteries of interstellar travel, we inch closer to the possibility of venturing beyond our solar system and exploring the wonders of the universe.